Yes, welcome back. How are you? I hope you actually had a break. Now, I hope you are still continuing. I know some of you are very much panicking. They want to actually get this done. They want to go home and check the other stuff. Fine. We are still going to continue with this. We are actually here. We are now here. We are actually now at finding the x values of the turning point, which we call our critical values. Remember, I showed you how you can be able to use your calculator if you cannot be able to factorize that. If you find it very hard to factorize, you can actually use a calculator so that it can help you how to factorize. Okay. So in this case, after finding these two x-intercepts, after finding these two critical values, these are the critical values, the x values of the critical. These are the x values of the turning point. So now we must take these values and substitute them into the original equation. Which one is the original equation? It is f. Okay. It's f at x. Is f at x, which is equal to x minus 2 all squared into x plus 3. Okay, now we have to substitute each one of these critical values into the function. Okay, so let's work now. Let's check. We're going to substitute the first one, 2 is equal to 2 minus 2. In the position of x, I substituted 2 all squared and 2 plus 3. Okay, everybody happy? Then from there, we simplify this. X is 2 minus 2. 2 minus 2 is 0. 2 plus 3 is 5. Okay, so what are you going to have? 0, 0 squared is 0, multiply by 5, so it's a 0. Therefore, the function of f at 2 is going to give us 0. Then the point 2 and 0 becomes one of the turning points. Does this look familiar? 2 and 0? Do you remember we managed to get some 2 and 0 somewhere? You remember that? 2 and 0, we managed to get 2 and 0 when we were calculating the x-intercepts. Remember, right here. 2 and 0, it was an x-intercept. So the point 2 and 0, it is the same point again as the turning point. Can you see that? You remember what the teacher said? Yes, he said, if your equation has one of the factors repeating itself, like this, x minus 2 all squared, that same factor, that same value of x, which is the x-intercept, is going to act again as a what? As a what? As a turning point. Yes, it was correct. Can you see now we managed to get x minus 2? X minus 2, which was the x-intercept, you get it as an x-intercept. After getting it as an x-intercept, it now appears here as a turning point. Therefore, if your equation looks like this, please always remember that the turning point and the x-intercept are the same. Are you happy now? Thank you. So, now let's continue to the next one. We actually use the value x2 to substitute into the function. Okay, now we are going to substitute negative 4 over 3. Ooh, a fraction. A fraction. Are you afraid of fractions? Nah, don't be afraid. I'll tell you how to do it. Now let's do it. It's f at negative 4 over 3. It's negative 4 over 3. Where are we substituting? We are substituting into the original equation. What's the original equation? There is it. X minus 2 all squared into x plus 3. In the position of x, negative 4 over 3 minus 2 all squared and negative 4 over 3 plus how much? Plus 3. It is negative 4 over 3 minus 2 squared. Remember, you must work very carefully. Careful. Negative 4 over 3 is the simple position of x. Negative 4 over 3, it was plus, it's plus there, it's plus here, minus there, it's minus here. You become very careful when you substitute. Now from there you can actually work this out. You know what you can use? You can use your calculator in this case again. No problem, don't worry. You can use your calculator, but correctly please substitute that. Let's go into the calculator. There is your calculator, the bracket, and your fraction, it is going to be negative, how much? 4 over 3. Okay, 4 over 3. Next is minus 2. You close your bracket, and all this is squared. You see that? It is squared, so in this case this becomes squared, and then next it's going to be again negative fraction 4 over 3, and next plus 3, close the bracket, voila. Then you check please check please whether you substituted everything correctly, whether what you have written here is exactly looking as that, so that the answer that comes out of this, you know it is a correct answer. Okay, now let's check the answer. It's going to be 500 over 27. 500 over 27, negative 4 over 3, minus 2 all squared into negative 4 over 3 plus 3. Can you see that? You must always verify whether you have what you have written there is exactly the same as that. What you have written there is exactly the same as that. So you get how much? 500 over 3. Now you write your coordinates of the turning point. They become negative 4 over 3. It's the value of x. Okay? The value of y, 500 over 27. Remember, you must plot these points, 4 over 3 on your Cartesian plane, as well as 500 over 27 on the Cartesian plane. No mistakes, okay? So, but now, some of you may have a problem of what is going to be negative 4,3. Maybe negative 4 over 3. You can actually represent this in terms of commas. It is approximately maybe to 2 or 1 decimal place. Let's check the 500 over 27. It's about, this is negative 4 over 3. It's about 1,3. Okay, approximately 1,3, and this one is 18,5. Is everybody happy? Nice. This we can be able to see on the function, and there is it. And now we are ready to sketch the curve. Remember what the question said? You must actually show clearly all the intercepts on the axis as well as the coordinates of the turning point. Okay, this is what we must actually be able to show. Right, now let's go back to our screen. There is it. Now 2 and 0, 1 over 3 and 18,5. Is that fine? Yes, 18,5. We're going to use this and this. Now here comes an interesting part, sketching the curve. Remember, when we sketch the curve, our curve in this case, check what the value of the equation was. The equation, remember, it is f at x is equal to x minus 2 squared into x plus 3. Okay, so this is it. This is our equation, and this equation, when you remove the bracket and write it in the standard form, it looks as x cubed. You can check it from where we are actually finding the turning point. Look back where we were finding the turning point. Here is it. When we're finding the turning point, this was the standard form. It is in the form of ax cubed plus bx plus cx plus d. This is the equation. Everybody happy? Fine. Now let's check. This is negative x squared, carefully, minus 18x plus 12. We must always ensure that what is written there, it is written here. Okay, so that may not forfeit marks. Right. Next, guys. What is next now? We are actually going to be in the position to sketch the curve now. Remember what I said about the curve. We said when the value of A is less than 0, our curve is up on the left and down on the right. When it is A is positive, when the leading coefficient is positive, it's up on the left, it's down on the left and up on the right. So which case do we have? In this case, what is the coefficient of A? In this case, A is greater than 0 and therefore our curve should look like that. Is everybody happy? Right, our curve should look like that. So A is greater than 0, our curve is going to look like this. Now, sketching the curve. There are two ways that I'm going to show you that you can be able to sketch the curve. The first thing that you can do, you can just sketch a curve which looks like this. Make it very smooth, like this. I'm going to show you two methods. This is method 1. Method 1. In this method, just sketch the curve as it is. Just a smooth curve, just like this. On free hand, just sketch it. Don't be afraid, please. Sketch your curve. It must be very smooth, having a turning point, and it is there. Can you see? I've sketched the curve. It looks very smooth, and I know that I'm going to have my turning points here and there. Remember, we have two turning points, this one and this one. Now, what is the problem? The problem is that we don't know which one is first here. So if we know that the coefficient of the leading coefficient here is greater than 0, okay, Polani, when A is greater than 0 here, can you see that the leading coefficient is greater than 0? Your graph looks like this, okay? Now, what will be the first turning point? What will be the second turning point? That's 7. You have a problem with that? No. Ensure that you write your turning points in the ascending order, the x values of the turning point, this one and this one, in an ascending order from small to big. Remember what comes first. If you have negative 4 over 3, this is negative 1, 3, negative 1, 3, careful. You see what I'm talking about? It's negative 1, 3. So the values on the number line, it should be look like negative 1, 3, and then followed by how much? By 2. And then from there you check how many x-intercepts do you have. How many x-intercepts do you have? Do you remember your x-intercept? Let's go back quickly. Go back and check your x-intercepts. Here are they. Where are your x-intercepts? These are the x-intercepts. 1, 2. You have 2 roots. You remember what I said? I said the cubic function can either have 1, it can have 2, or 3 roots. So in this case, there are 3 roots. So how is it going to look like? Therefore, if there are 2 roots, it means your graph is cutting the x-axis twice. So when it cuts the x-axis twice, let's go to our curve and let me show you that. If I draw the line here, can I do this with the ruler? Can you see I'm having how many points? It's 1. Show me, see. If I cut this here, it's going to be 1, 2, as well as 3. In this case, there are 3. For them to be 2, I must move this line either vertically down or vertically up. When I move it here, can you see how many x-intercepts I'm having now? I'm having this one as well as that one. I'm having 2, which is the ideal situation in this case. And then in this case, I'm actually having it here as well as over there. Can you see that? I'm having 2 x-intercepts. So my line, which is going to be in the x-axis, are either going to pass here or are going to pass here. But if they pass here, let's check if we say maybe they pass here. The point that we are going to have here is going to be the smaller ones of this 2, which is going to be negative 1 over 3 is going to be here. It's going to be negative 1 over 3 here, and then the next one is going to be 2. Can you see that? It's negative 1 over 3 here, and the next one is going to be 2. You must also check when you actually draw that. And then when you actually put it here, it's going to be negative 1 over 3 here, followed by 2. Where are we going to put it? Are we actually going to put it here or there? Check something. When you put it here, let's assume that we put it here. So let's check. We are going to say this will be the first turning point. What is the turning point? It will be negative 1 over 3, and what is going to be the corresponding value of y? 18,5. Is it? And this one is going to be 2 and 0. So practically, let's check what is going to happen. If we try to put the y-axis must be somewhere between negative 1 over 3 and 0. If you put maybe y-axis somewhere here, can you see what we're having? We are having negative 1 over 3, which corresponds to 18,5. And this cannot be 18,5 if we assume that these are the y-axis. Can you see that? We cannot have 18,5 here. So because of that, we cannot put our x-axis over or to that point. So we have to actually remove them and put them to the other side. You can see that on this side they are not working. So let's put them here. Possibly there are only choices, either up or down, and definitely we are going to get the answer here. In this case, if you put it here, and then from there you check the nature of your turning points. Can you see this one is negative 1 over 3 and 18,5. So it's going to be higher when you put the y-axis. It's going to be higher than 0 down there. So definitely this, in this case, this is going to be your x-axis. Your x-axis will be passing through here. You'll be passing through here. Your x-axis will be passing through here, and then from there your y-axis in this case is going to be 2, and somewhere here is going to be negative 4 over 3, which is how much? Which is 1,3, negative 1,3. So from here, if it is 2 here and it is 1,3, approximately the y-axis are going to be drawn somewhere here. Nice. That's it. So your y-axis, x-axis, your 0 is here. Ensure that you label them, because if you don't label them, we don't know what they are. This is a curve of f. Remember what the question said? You must clearly show the intercept with the axis. Do you remember this one? Let's go back and check. Negative 3 and 2. See that? Is negative 3 and 2. So if it is negative 3 and 2, it means if it is 2 is here, and this one will become negative 3. Nice. Doesn't it look nice? Okay. I hope you are actually coping there. Let's check. Now, in this case, what is here? The y-intercept. How much is your y-intercept? You must also check. Go back and check where you calculate the y-intercept. Here is a point. 0 and 12. Go back. Put 12 here. What are the coordinates here? 2 and 0. What are the coordinates here? It's about 18,5, which is 500 over 27. We said it's 500 over 27. This is going to be the coordinates of the turning point. There's it. I said, I can show you the two methods that you can actually draw this. Actually first draw this one by actually sketching the curve there. After sketching the curve, and then you actually do your calculation. The second method of sketching this, the method 2, you can do this. Method 2. 2, in this case, method 2, you can actually draw your axis first. Draw your axis. All right. Draw your axis. And then your axis, accurately so, this aside. Draw your axis. Y-axis as well as your x-axis, and then from there on these, this is x and y. Please ensure that you label them. This is 0 here, okay? And then from there you check the type of points you are having, okay? Remember, you have the turning point and the x-intercept. Let me start with the x-intercept. It is 2 and 0 as well as -3 and 0. Can you check that? Yes, it's -3 and 0. These are the x-intercepts. And then from there, the turning point, the y-intercept, we have a 0 and how much? And 12. And 12, these are your y-intercept. The turning point is the same as that one. It is, the turning point is 2 and 0 and what? And -4 over 3 and -4 over 3 and what? And 500 over 27. Remember, we said this is approximately 18,5 and this one is approximately -1,3. Now, with all these points, if you want to do your scale on the x-axis, can you see on the x-axis the values we have? We have a 2, 3, and 2, as well as 1,3. So with these values, they actually can predict the type of scale that you can actually use on your x-axis. In this case, you can take your ruler, and then from there, you must actually have a 3 here, okay? So you can actually say maybe 1, 2, 3, 4. It's fine. Then from this side, 1, 2, 3. You know why I'm making this? So that you can be able to cover -3 and 2. So in this case, you can have 1, 2, 3. Let me put it there so that you can see. -1, -2, -3, -4. -1, -2, -3, and 4. Now look at the vertical scale. Can you see on the vertical scale, the highest value we have 18,5. The smallest we have a 12. So you can also decide the vertical scale here. You can see what I've drawn here. In this case, I'm only having 1, 2, 3 values that I can actually use. So what I can say in this case, we can maybe say 4, 8, 12. If it ends at 12, I'm not going to see 18. Okay? If it ends at 12 here, I'm not going to see 18. So I can say maybe 5, 10, 15. Even 15, I'm not going to see 18. So I can go 6, 12, 18. If I go 6, 12, 18, I'm having a problem again. Actually, I'm having 18,5 here. So what I can use here, can use 7, 14, 21. I can say 7, 14, and 21. Can you see that? I'm doing this so that I can be able to cover these values, 18,5 as well as 12 on this scale. Okay. And now from there, I'm going to estimate my points. So now, 2 and 0 is this one. -3 is this one. Now, the y-intercept is at 12. This is 7. This is 14. So you can actually estimate where your 12 can be. In this case, if it's 7, somewhere in between here, you'll be actually having a 10. So approximately 12 is going to be somewhere there. Your 12 is going to be here as the y-intercept, and then you have 18,5, 14. You can actually estimate somewhere here to be 18,5. Can you see I've actually drawn the scale that side? And then from here now, you can check your turning points. 1,3, -1,3 is somewhere here. somewhere up there, negative 1 comma 3, somewhere up there. And then from there your 18 comma 5, your 18 comma 5. Sorry, can you see it? My turning point is going to be exactly there. And therefore my curve will be moving like this, curving at that point, passing at 12, going at 2, going exactly at 2 there, and up it goes. Can you see that? Nice. There is your curve. You label it F. How nice. Okay, so you have actually managed to draw your two curves. They exactly look nice. So it depends on what method you want to use. You can actually sketch the curve first, and then from there you estimate the points, or you do your Cartesian plane. And when you do your Cartesian plane, ensure that you study your points, all your points, which one is the smallest, they were the biggest ones, and then so that you can correctly estimate your points. All right, now let's get to the next question. Our next question in this case was this one. You wanted to do this one as the next question there. But in this case, can you just take this one and just do it as a home fun, okay? I'll show you the solution at the end of this session. But for now, I wanted you to do the following curve. Can you check this one? In this case, we want you to sketch the curve. If f at x, in this case, f at x is equal to ax cubed plus bx squared plus cx, the following information is given about this graph. They say f at negative 3 is 8. And f prime, can you see that? It's prime there. F prime at negative 1 is equal to 0. Then f prime, derivative at 5 is equal to 0. Then f at x is increasing for x being greater than negative 1 and less than 5. So you'll be using this information to sketch your curve. Okay, can you quickly look at this? And I'm going to give you only 3 minutes. 3 minutes, I want to check your curves, whether you can be able to use this information to sketch your curve. Can you quickly do that in 3 minutes? Starting now. All right, we are back. Let's now check. Did you manage to draw the curve? Did you manage to study the information? What is the information said? Can you check here? We said f at negative 3 is equal to f at 8 is equal to 0. What is the meaning of this? Can you quickly check in the problem, the last problem that you did? When we last wrote f at something equal to 0. Did you wrote it somewhere? F at 0? Yes, if you have, let me just show you here. In this case, the problem says f at negative 3 is equal to 0. What type of a point is this? This is the value of x, and if you substitute the value of x into the function, you get the value of y. Therefore, the point in this case is negative 3 and 0. Negative 3 and 0 is a point. What type of a point is this? Where you have a y value being equal to 0? Yes, of course, it is the x-intercept. Correct? That is the x-intercept. And the next one is also the x-intercept because it was written as x. F at 8, here goes your x, is equal to 0. Then you have 8 and 0. And of course, the 2 becomes the x-intercept. Therefore, the information which was given, it was telling us that these are the x-intercepts. Now, the next information given was this. The derivative at negative 1 is equal to 0. What did we say about the derivative? We said the derivative is a gradient, or the slope, at -1 is equal to 0. So when is the gradient equal to 0? When do we have a gradient being equal to 0? At the turning point. At the turning point, the gradient is equal to 0. Fine. So at the turning point, the gradient is equal to 0. Therefore, this point is a turning point. It is actually having -1 and, did you say 0? No. The 0 here is a 0 for the gradient. It is not 0 for the y. You can just put any value of y here, but don't put any value of y yet, but it's a value of y of which you don't know yet now. What is it? Okay, we don't care about what is it now. The only thing that we care about is the x value. But you cannot say this is not y. This is the gradient. So in this gradient, it is a gradient when x is equal to -1. So when x is equal to -1, the gradient is equal to 0. So what type of the point is this? It is a turning point. At the turning point, the derivative is equal to 0. The next one, f derivative at 5. F divided 5 is how much? It is equal to 0 again. What type of a point? It's still the turning point. Therefore, we are having a turning point 5 and the value of y, of which we are not sure of. So these are the two values of y. We are given the turning. We are given the turning points. We are given the x-intercepts there. So is it difficult to find to actually estimate the graph here? Not at all. The type of the other information that you are given that the function is increasing. Can we check that information? We said the function is increasing. The function is increasing between -1 and 5. So do you understand when the function increases? When the function is increasing, it means from left to right, it is actually going up. It is when the function is increasing. Remember, if you have a curve, if we have a curve here, let me actually show you a curve. Here, the function is not increasing or decreasing. It is stationary. No. It is actually stationary here, and also here it is also stationary. But from left to right here, the function is actually increasing, positively so. It is actually increasing, reaching the turning point when it becomes stationary. That is when the derivative is equal to 0. And thereafter going down, decreasing. Can you see that? Then reaching again the stationary point, then it starts to increase again. It is increasing. So what does the question say? It says between -1 and 5, the function is increasing. Therefore, possibly we are talking about a situation like this. Because we have the two turning points. We are talking about a situation like this. Because they say, can you see in this case, this is stationary point. These are stationary points. And therefore, what is happening from left to right? The function is decreasing, reaching the turning point. Then after that, it starts to increase. The function increases up to there. And then from there, it starts to decrease again. Fair enough? So what did they say? They say our question says in this case, the function is increasing between the two critical values, between x is equal to -1 and x is equal to 5. Therefore, possibly this is a type of situation we are having. So when you estimate our curve should possibly look like this and not definitely like that, because they say between the two critical values, which are the critical values, the turning points, your graph is increasing. Your graph is increasing between -1 and 5. So if your graph is increasing between -1 and 5, it means you have a shape looking like this. But in this case, can you see, if you maybe thought that this was the correct answer, can you see what is going to happen between the two critical values? The graph was going to decrease. So when the graph decreases between this value and this value, that's not what we want. We are actually looking for where the graph is increasing between this and this. Therefore, our curve is going to be this one. So we are going to sketch and estimate the curve. Can you see what I'm doing here? Our curve is going to look like this. And then we also have two x-intercepts. The other one here, can you remember what is the value of x here? The value of x here at the turning point, it should be -1. And the value here of y over this one, it should be negative. Is it negative? It's +5 here. Okay, it's +5, it is -1. Everybody happy? So these are going to be the critical points. Now, you have the x-intercept, two x-intercepts. The other one is, let's go back and check, -3 and 0 as well as 8. Now, we are going to try to move this line so that we can actually see where possibly we can have our line. Let me use this ruler here. If we have this, can you see if I use this ruler? If we cut, if the x-axis, maybe we're supposed to be here. How many x-intercepts we are going to have? We're going to have this one and this one. But by the look here, if we look there, we are supposed to be having -3 and 0. If we say this, it should be -3. Therefore, the value that we thought it was -1 is not supposed. Can you see they won't match here? It's not supposed to be here. It's supposed to be somewhere else. So let's try to move our x-axis down a bit here maybe. If we move them here, we are going to have a value here, which is how much? -3. We can estimate this is going to be -3 here. And over there, after 5 may be supposed to be somewhere here on this line. So somewhere there after 5 we can have our another x-intercept. Only two x-intercepts were given. So can you see if I place this x-axis here, then we can be able to estimate correctly these two values, the -3 as well as 8. Okay, so we can possibly throw our line here, even if I can push it maybe somewhere down here a little and say -1. Can you see the -1? -1 here. Can you see that? -1 and -1 and that. Do you remember what we said here? It's supposed to be increasing. Do you see I'm using the decreasing one? Can you see that? If I'm using the decreasing one, this is supposed to be increasing. Can you see that? This is decreasing. Even though I can estimate this and say the x-axis are there. But the question said between -1 and this value, this is supposed to be increasing. Can you see that? So this curve, it cannot be correct. No. So therefore, the correct curve was supposed to look like this. You see that? Because now, in this case, between these, this is going to decrease, as I've shown you before. Okay, so because of that, estimating this is going to be our 5. This is going to be our -1. Because the reason is, the fact is that in this case, even if we can say 8 and we can say here -3, but for the fact that between -1 and 5, the graph is decreasing, then we are actually going to miss this particular point. Okay, the turning points will be fine, the x-intercept will be fine, but we are going to miss this information. So because of that, the correct curve is supposed to look like this. And then, look at that. Now let's check here. This is going to be your x-axis. And then if it is -1 here, maybe possibly the y-axis is somewhere here. The y-axis are supposed to be somewhere here. Now, let's check this. Does this correspond with the increasing? Between -1 and 5, the curve is increasing. Can you see? In this case, everything is correct here. But the only part that we missed is the decreasing. But now, if you check this one, between -1 and 5, the curve was supposed to be increasing, not decreasing. Okay, so this is going to be our correct curve. Not that one. Yeah, that one is only going to be the missing part there. All right. So everybody happy? Fine. Therefore, we have managed to do that part. Okay. Now, let's get to our next question here. The next question here is actually coming from your paper, the March paper. All right, I know you have done this question a number of times, but there are very interesting things that I want to discuss with you with this one. I only left with about 10-15 minutes, about 10 minutes. And then because of that, I want you to actually check these questions very carefully. We have managed to draw the curve. We have drawn the curve. We've given the equation. We can find the curve. But in this case, what if we are given the curve and we have to find the values in the curve? Right. Let's get back to work. Now let's check. In this graph, the information that we are given there is that, let me write this quickly, y is equal to ax cubed plus cx, can you see that, plus cx plus, okay, it's minus 2, which is the equation of f, and the one of g is x minus 2. Can you see that? Those are the two equations. They say the graph below represents the curve of f at x, which is actually ax squared plus cx minus 2, and the one of g at x, which is actually given as x minus 2. So the point A, which is the point here, is given. Point A, which is here, and this one, which is -1 and 0, they are given. Those are the x-intercepts. Therefore, the graph have the x-intercepts at this point, which is given, and this one, which is point A, which is actually given there. So what we need to find in this case, you need to find the graph, okay, they also intersect at A and C. The 2 points A and C are the point of intersection. Do you remember what is happening at the point of intersection? At the point of intersection, the two graphs are equal. They share the same coordinates. At this point and this point, the two graphs are going to be equal. So in this case, let's check the question. Determine the coordinates of A, which is this. Can you see how many marks there? It's only 1 mark. Meaning that if you have to answer the question, finding the coordinates of point A, the coordinates, I want you to underline the word, the coordinates of point A. If you have to find the coordinates of point A, the coordinates of point A, it is where the graph of f cuts the x-axis. It is where the graph of G cuts the x-axis. So if we have to find the coordinates of point A, let's say we try to use f. What we have to find for f? F is actually having the x-intercept at point A. So we have to use the equation of f to calculate the coordinates of point A. So if we have to use it, can you check what is happening? F, it is having two unknowns, the value of A as well as the value of C. Those are the two unknowns. So we have to find the value of the two unknowns even before we can be able to solve for x here. So in this case, f cannot work for us. Okay, so we will use G. All right, let's show how we are going to use G. So G, in this case, at A, point A for the graph of G is the x-intercept. x-intercept. Okay, it is the x-intercept. Okay, so when it is the x-intercept, we are going to have to find the x-intercept of this graph. You remember this is a graph of G. Y is equal to x minus 2. Then for x-intercept, what do? Y must be equal to 0. You put your y to be equal to 0 here, and then it's equals to x minus 2. Then you solving for x, you get x to be equal to 2. Now, what did the question said? It said find the coordinates, not the x value of A, coordinates of point A. Coordinates of point A. Coordinates are supposed to be in x and y. So in this case, using x and y, the value of x, the coordinates of point A, x comes here, it's 2. Y, it is that value, 0 there. Then this is where your 1 mark get. You don't get the marks here by actually saying x is equal to 2. That is not correct. The coordinates must be that. Alright, let's check the second one. The second one, in this case, you are supposed to actually show by calculation that A is equal to -3. Guys, you have a tendency of thinking that even if you didn't actually find these questions and write them as they are and say A is equal to -1 and C is equal to -3 because it is given. That is not how it goes, okay? You have to actually show by calculation that A is equal to 1 and C is equal to -3. Don't just substitute those values there and just take any value and prove that when you substitute the value there, then A is equal to 1. No, you have to prove by calculation that A is equal to 1. So, let's quickly check this. Now, we can use about 2 methods in this case. Let's check this. In this case, when you do 11.2, we can find the derivative. After finding the derivative of f, we know that at -1, okay, the derivative at -1 is equal to 0. When you find the derivative at -1, remember this is the turning point, is equal to 0. So you get 3a plus c equals to 0, and you call this your first equation. And then from there, you go, next step, you find f at -1. You substitute f at -1, remember, is also the x-intercept. You substitute it directly, not in the differentiated equation, into the equation of f, and then you get f at 1. At -1, which is -a, because you are actually multiplying there, and then you are going to get this. Remember, this is because it is the x-intercept. So if it is the x-intercept, then you actually get the equation here, then you call that equation 2. You divide that by negative there. And then from there, you solve the 2 equations simultaneously. Equation 3, you take equation 1, and you make C the subject of the formula here. C is equal to -3a, and then you substitute in the position of C, how much? -3a. Can you see that? And then you get -2a being equal to this. In this case, you have managed to prove that a is equal to 1. Then to b, then you take a is equal to 1, then you substitute there, substitute a here. Remember, this is this equation. You substitute here 1, which is there, and then you get your c is equal to -3. So in this case, you did manage to actually show that the value of A is equal to 1, the value of C is equal to -3. Okay, there are other methods that you can use. I can quickly show you that. I can just quickly follow the screen here. In this case, you can actually see that. In this case, I've also again substituted a +1 here. I've substituted -1 here into the equation, and then it is equal to 0, and I get the first equation. I differentiated, I substituted the -1. Almost it's the same equation. Can you see that? But now in this case, when it arrives here, I'm no longer using substitution. I'm going to take the 2 equations and add them. And when I add the 2 equations, this is the answer I'm getting. If I get this, then get 2a is equal to that. This is elimination. Then from there, you're still going to get the value of a is equal to -3. That's it. Then we've managed to actually solve the problem that is actually looking for the value of A being equal to -1 and C is equal to -3. But sometimes there is a problem of you not being able to find the value of A and not finding the value of C. Come on, guys, don't panic. Sometimes you find that this problem is actually giving you, it's actually wasting your time. You cannot be able to get through this. You can jump from 11.2 and go to 11.2, but when you arrive at 11.3 from 11.2, you actually use the value A is equal to -1 and C is equal to -1. Substitute it into the equation there. Substitute it into the equation there, and then from there use that equation to find the turning point. So the equation will be looking like this. F, I'll show you shortly, is going to be x cubed minus 3x minus 2. So the equation is going to look like this. And then from here, you can now differentiate. When you differentiate, you'll be getting 3x squared minus 3 as a derivative. Then dividing by 3 here, when you actually make this, you're going to get the coordinates of the turning point of which you are actually looking for here. So please, guys, sometimes if you cannot be able to do that one, showing that this is equal to that, you can actually directly use it into the next question and be able to follow the question. All right. So I think we actually had a nice discussion concerning sketching the curve. After sketching the curve, and then from there, if you have sketched the curve, you can also be given a curve so that you can be able to interpret the curve. So I hope, guys, that you managed to get all these points very carefully. You must also go and make sure that you actually get enough rest. Get enough rest so that you can be able to write tomorrow being fine. Okay, so ensure that please know your calculator. You have to know how to use that calculator. Don't make mistakes. Ensure that you work from step to step carefully. Ensure that the first question you get it all. That one is compulsory. If you don't get that question one correctly, I'm telling you, then it means I'm going to ensure that when you come out of the examination, I'm going to send my kid so that it can lick your food. Okay, please ensure that you answer all the questions. So guys, up to here, I think our time is up now. And then from here, please, guys, good luck. Ensure that you actually write nice tomorrow, and I hope everything is going to be right. You're going to pass your examination. Don't panic. Get into the examination early. Sit there. You're going to be given minutes so that you can study your paper. Ensure that you take all the questions, study them, and check with the questions. Which question are you going to start with? That will be a very nice exercise, that one. And then from there, you attempt those questions. Okay? Good luck, guys. Goodbye.